Okay, so this is a summary. So strings with a knots at the both end, and then open end air column with anti-knot at both end. And then when it comes to a closed end air column, you have one knot and one anti-knot. So that is the main main difference, and that is the things that you have to memorize. Because once you know the characteristics of these three applications, you will know how to sketch the standing wave for each of the applications. Okay, now let's go through exercise 4. So exercise 4, first one, now you look at the questions. The questions say a stretch wire. So this is actually an example of a string. Okay, so now you have a string-like object. So this is an application of strings. So a stretch wire of length 80 cm, this is L, and a mass of 12 gram pivots transversely. So the wave travel along the wires at a speed. So we are given the speed inside the strings, and 3 anti-knots can be found in the stationary waveform in between two fixed ends of wire. So how to sketch this diagram? Well, if you know, when it comes to an application of a string, okay, you must have both ends. Okay, both knots, the knots at the both end. So how are we going to sketch? Now, in case you don't know the exact shapes, what I would suggest you to do, you sketch the shape of the stationary wave first, and then you crop out the part that you want. So for example, now this is the shape of a stationary wave. Okay, so I don't know which part I want to use yet. So what am I going to do? I'm just going to sketch a basic diagram for a stationary wave. Okay, so this is our, yeah. So this is my stationary wave. I'm going to use different color. Okay, so stationary wave. Okay, stationary wave. So according to the questions, now I want a wave with 3 anti-knots in between two fixed ends. Okay, so now let's see. Let me label the diagram first. So this is knot, okay, and then anti-knot, 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 and anti-knot here, okay, and so on. So according to the questions, now I just want 3 anti-knots, okay, which means this is the anti-knot that I want to keep, this is the anti-knot that I want to keep, and this is also the anti-knots that I want to keep. And according to the question, this is an application of string. So when it comes to application of strings, I should have knots at both ends. So I'm going to take the knots in front of the first anti-knot, which is here, and the knots behind the last anti-knot, which is here. So I'm going to crop this out. Okay, I'm going to crop this out. And this would be the answer for questions A. Right, so now I'm going to redraw it. Okay, I'm going to redraw it as the answer for questions A. So this is 2 fixed end. Okay, this is 2 fixed end. So according to a diagram that I sketched just now, this is the part that I want to keep. Okay, from here until here, because I will have 3 anti-knots in between these 2 fixed ends. So I'm going to move this whole stationary wave out and put it in my answer. Okay, so it looks like this. So this is knot, and this is knot, and then I'm going to draw it in another directions. Done. That is the answer for questions A. Okay, I have knots at both ends, and then this is anti-knot, 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 with 3 anti-knots in between 2 fixed ends. So sketch and label the waveform of a stationary wave. Now I have 2 fixed ends with knot and 3 anti-knots in between them. And don't forget, because now you're given the length in between 2 knots, therefore you need to label it in your diagram. So L is equals to 80 cm. So that is the final answer for your questions A. Okay, so in exam, in case you don't know how to sketch a diagram, this is how you do it. You sketch the general shape first, okay, the general diagram for stationary wave, and then you crop out the part that you want. Either it starts from knots or either it starts from anti-knots. Depends on which type of applications you're looking at. Okay, now let's look at questions B. So questions B, the wavelength of progressive wave which move along the wire. So first of all, you need to know, okay, what is the general equations between the length given and also the wavelength. So when it comes to strings, we know L is equals to n lambda over 2, okay, n lambda over 2. And then according to the diagrams given, what I have right now, okay, I have a note. Okay, so this is the first note, which is the first harmonic, second harmonic, third harmonic. So according to the diagram that I sketched, okay, now I have third harmonic, which is n is equals to 3. Okay, so how do I know? Let's okay, I'm going to repeat it again. So you look at the diagram in the purple color. Okay, this diagram. So this is note, all right? From first note until the following note, this is my first harmonic. Okay, this is my first harmonic. Second note, this would be my second harmonic. And this is a third note. So now I have third harmonic in these questions. Okay, because with three empty notes in between them, and I can have three notes here as well. So from the first note until the following note, this is my first harmonic. First note to the second note, that is my second harmonic. But now I have first note to the third note. So this is the third harmonic. Okay, so I have three third harmonic questions. So L equals to n lambda over 2, and according to my diagram, my n is equal to 3. So now that I have n equals 3, and then I know that my L is equals to 80 cm, which is 0.8 meter. So rearrange the questions. Okay, rearrange the questions. I have 0.8 times 2 equals to 0.8 times 2 divided by 3 equals to lambda. Therefore, lambda is equals to 0.533 meter. So that is the answer. Okay, that is the answer. And that is how you solve it. So the first things that you need to know when it comes to applications of stationary wave, first is to sketch the diagram. And then you have to know what is the relationship between the L and also lambda. Right? Once you know these two things, then it should be easy for you to solve any questions in 10.4. Okay, next one, the frequency of a vibrations of the wire. So now you want frequency. What is the equations that contains frequency? Now when it comes to applications of stationary wave, there's only one equations that come with a frequency, which is V equals to F lambda. Okay, so given V is equals to 220, V equals to 220, M as negative 1. And then, according to the previous questions, lambda is equals to 0.533 meter. So you plug it in and rearrange the equations. Eventually, you will obtain F equals to 413 hertz. So that is the answer for second questions. And then the last one, the tensions in the wire. So when it comes to strings, other than the general equations V equals to F lambda, okay, V it actually has another equation. So which is V equals to square root T over mu. Okay, square root T over mu. Now we don't have the value for mu, but what we do know is mu is equals to mass over length. Okay, mass over the length of the strings. So given mass is equals to 12 gram, okay, which is equals to 12 times 10 to the power of negative 3 kg divided by the length, which is 0.8 meter. Therefore, mu is then equals to 0.015 kg and negative 1. So that is mu now. Now that you have mu, and then you have the velocity, you should be able to find, okay, to determine the values of tensions. So T is equals to 726 Newton. Right? So you plug in and then you solve it. Okay, you plug it in and then you solve it. So now I give you 2 minutes to write it down. If you have any questions, you may ask before we proceed to questions number 2. All right, 2 minutes for you to write it down. Okay, so now let's look at questions number 2. So questions number 2, a tube 60 cm long is closed at one end. So this is the keyword. Okay, this is the keyword, closed at one end. So which tells you this is an examples of closed end air column. Okay, or closed end pipe. So this is what we call closed end pipe. Resonance occurs and a vibrating air column in the tube produce sound of frequency 992 Hz. So we have frequency here. And the third overtone mode is found in the air column. So now you have third overtone. Okay, third overtone. So how are we going to sketch the diagram? Questions A asks us to sketch the diagram. So what should we do? So again, if you don't know how to solve it, how to do, then you sketch a diagram first. Okay, you sketch a diagram first. So the general shape for stationary wave. Okay, the general shape. And then, okay, so this is the other wave. Okay, now let me label the diagram as usual. So note, anti-note, note, anti-note, note, anti-note, note, anti-note, note, anti-note. Okay, now let's see. When you have a closed-end air column, okay, what should we do? So according to the closed-end air column, we will have one note and one anti-note. Okay, so it is up to you whether you want to start from notes or you want to start from anti-notes, okay, based on the general shape, how you want to crop it. So let's say now if I want to start from notes, okay, I want to start from notes, and according to questions, I need the third overtone. Okay, I need a third overtone, which means I need to have 3 anti-notes. Okay, I need to have 3 anti-notes right here. So, well, actually should be 4 because don't forget about the fundamental frequency, which is a first harmonic. So when it comes to closed-end air column, remember you have only odd numbers harmonic. Okay, so for third overtone, actually it goes up to 7 harmonic. Okay, why? Okay, now let's see. Where fundamental frequency, okay, fundamental frequency, which is our first harmonic. First overtone, which is our second, third harmonic, okay, because we have only odd number. And then second overtone, okay, second overtone, this is n equals to 5. And then when it comes to third overtone, we have n equals to 7. Okay, which means what we need to do right now, we need to have 4 anti-notes in our diagram. Okay, 4 anti-notes. Oops. 4A in our diagram. So let us start from N. Okay, let us start from N. So this is my first anti-note. This is my second anti-note. This is my third anti-note. And this is my fourth anti-note. So I'm going to crop it out here. Okay, I'm going to crop it out here. And then I'm going to crop it. So this part would be my final answer. Okay, this part would be my final answer. So now I want to redraw it in a tidy way. So this is my closed-end air column. It is up to you whether you want to close on the right-hand side or on the left-hand side. Okay, so now let's see. This is my note. So this is the part that I want to crop out. Okay, from here until here, I want to crop out from my diagram. So let's see. Anti-note, anti-note, NT node, and when you reach the open end again is NT node. Okay, so remember, when it comes to closed-end air column, you have node at one end and NT node at the other end. So now I'm going to complete the diagram. Okay, so this is my diagram. So I have NT node, NT node, NT node, and here again is NT node. So 4 NT node, like I told you just now. Okay, why? Because it's third overtone. When you have a third overtone, means you have 4 types of harmonic here. N equals to 1, N equals to 3, N equals to 5, N equals to 7. So you can have 7 harmonics in the questions, in this question. Okay, so 4 antinodes should be drawn in your diagram. So nodes, antinodes, all together you have 4A here. Okay, 4 antinodes. So that is the answer for questions A. So again, don't forget to label the lengths because you are given the value. So the length from a closed end towards the open end is 60 cm. Okay, or you can label it as a 0.6 meter. Okay, you can label it as a 0.6 meter. So it's up to you. So this is the answer for questions A. Okay, answer for questions A. And then now questions B. Okay, let's look at questions B, the speed of sound in the air. You want to calculate the speed of sound. Okay, so even though we know it's a constant value, but since the questions ask you to calculate it, you cannot simply write down the value. You need to show how you obtain the value. Okay, so we know speed of sound is approximately 340 until 343. That is the value. But what we want to do right now is we want to prove it. Okay, we want to prove whether it's correct or not. So first things, if you want to calculate the speed, okay, now the speed in a closed-end air column, you have only one equation. It is unlike string. Strings, you can calculate speed by using 2 different equations, but when it comes to pipe, it doesn't matter whether you're looking at closed-end air column, closed-end pipe, or open-end pipe, you have only one equation to calculate the velocity or the speed, which is V equals to F lambda. So given F equals to 992 Hertz, now we don't have the values of lambda, but what we do have is the length. Okay, so when you have length, then you should be able to determine the values of wavelength. Because we know when it comes to a closed-end air column or closed-end pipe, L is equals to N lambda over 4. So L is equals to 0.6 meter. So 0.6 equals to, now N is equals to 7. So 7 lambda over 4. Rearrange the equations. Lambda is equals to 0.343 meter. Okay, lambda is equals to 0.343 meter. So plug it into the equations. V equals to F lambda. Then you'll be able to obtain V equals to 340 ms negative 1. Okay, V equals to 340 ms negative 1. So this is how we solve it. Okay, this is how we solve it. We start from the general equations, and then from there we identify the variable that is missing. And then we try to find those variables. We try to find those values. Okay, so question number 2. Okay, V2, the fundamental frequency. So for fundamental frequency, you have 2 equations. Either you use Fn equals to Nv over 4L, or you can use Fn equals to Nf1, okay, N times F1, the fundamental frequency. So a question asks us to calculate fundamental frequency, and given the frequency for third overtone, which is F7, given F7 is equals to 992, okay, 992 Hertz. So given F7 is equals to 992 Hertz, and then since it's a 7 harmonic, N equals to 7, therefore we can have 992 equals to 7 F1. So F1 is our fundamental frequency. Rearrange the equations, then F1 is equals to 142 Hertz. Okay, F1 is equals to 142 Hertz. So that is how we solve question number 2. Start from the diagram again, and then as you can see, I apply the equations L equals to N lambda over 4. The equations that that link L and lambda together. And then at last, I calculate the fundamental frequency by using Fn equals to n F1. And of course, if you want to calculate it by using NV over 4L, also can. Okay, also can. Now let's see how to apply the other equation, this equation. So if you want to calculate fundamental frequency by using NV over 4L, okay, so F1 equals to NV over 4L. Now, since it's fundamental frequency, N is equals to 1. So you plug in 1 here. And then V, according to a previous question, is 340 divided by 4 times 0.6. Okay, so you should be able to get a value that is close to or equals to 142 as well. So you have two different methods. Okay, so this is the first method. Okay, first method. And then this is the second method. So it is up to you which one you want to use, all right? There's no fixed answer in physics. So it's up to you. As long as it makes sense, as long as you answer it according to theory, then it's fine. Okay, now as usual, I give you 2 minutes to write it down before we proceed to next questions. If you have any questions, you may ask.
Dia ada
Okay, now let's move on to the next questions. Questions number 3. Questions number 3. Now you have a 2-meter long air column is open at both ends. So open at both ends, what does it mean? Now it means this is an open end pipe. Okay, open end pipe means the pipe is open at both ends. Okay, the pipe is open at both ends. So it comes with 2 antinodes. And then when you have an open end air column or open end pipe, we know L is equals to n lambda over 2. So this is the equations. This is a relationship between L and lambda when it comes to open end pipe. So the frequency of a certain harmonic, now you don't know what is the harmonic given, is 410 hertz. Okay, so what we do know is this is Fn. We don't know which harmonic, so I label it as n. It is equals to 410 hertz. And the next higher harmonic. Okay, so what happens in next higher harmonic? I'm going to call it Fn plus 1 equals to 492 hertz. Okay, 492 hertz. Determine the speed of sound in the air column. So the end correction may be neglected. Now, what does it mean by end corrections? So this is actually no longer in your syllabus, but I'm just going to explain it to you so that you understand what does it mean by end correction. Now, usually when it comes to a pipe, okay, so we say we should have the antinote on both ends. So for example, now I have antinotes here, and then I have antinotes here. Now, sometimes the antinotes, it won't end exactly at the ends, okay, at the ends of the pipe. So there would be a short end where there's no wave. This is what we call end correction. Okay, so there's another equation for you to calculate this end correction. But since it's no longer in our syllabus, what we do in our syllabus is we assume, okay, we assume that the wave, it ends right at the end of the pipe. So there is no correction. Okay, there's no end corrections in our case, in our questions. So the end corrections may be neglected. So calculate the speed of sound. So how are we going to calculate the speed of sound? You are given two frequency. That's it. Okay, that's it. So we know frequency. Okay, frequency is equals to NV over 2L when it comes to open end air column. Okay, because we cannot calculate it straight away. We cannot calculate V by using F lambda. We don't have lambda yet. Okay, so what we can do right now is we apply equations F equals to NV over 2L. So let's see, how are we going to solve it? So for first equations, Fn, okay, so Fn equals to 410 equals to NV over 2L. Okay, equals to NV over 2L. Now, V and L, I'm going to leave it, okay, because they should have the same value. Since you're looking at the same open end pipe, so they will have the same V, they will have the same L. And then the second equation is coming from Fn plus 1. So if you have Fn plus 1, okay, equals to 492, then the general equations would be N plus 1 V divided by 2L. Okay, so if you notice, I didn't put any subscript in V and also in L, because these two equations, they share the same V, they share the same L. So what am I going to do right now is, now I'm going to link these two equations together. But the questions would be how? How am I going to link them together? Okay, how am I going to link them together? So it's up to you. Okay, you can rearrange the equations. For example, now what am I going to do? I rearrange the equations to... okay, let's see. So I rearrange it. Now I obtain 2L equals to 4, oh, not 4, sorry. It should be NV divided by 410. Okay, or maybe I can move V over here as well. So now I move V to here. Okay, why? Because the other equations, I can obtain the same thing. I can have the same thing right here. So wait, yeah, let me rearrange it again. So if I rearrange the equations, okay, so NV, I'm going to do it step by step for you. So NV divided by 410 will be equals to 2L. And then rearrange it one more time. I have N over 410 equals to 2L over V. So I'm going to do the same thing for the next equations. Okay, for the next one. So I have N plus 1 times V divided by 492 equals to 2L. Rearrange it one more time. I have N plus 1 divided by 492 equals to 2L over V. Okay, just now should be V, not 4, sorry. So now that I have two equations, okay, I have these two equations, I can solve it simultaneously. So N over 410 is equals to N plus 1 over 492. Okay, so rearrange the equations. Okay, oh yeah, I want to find V, not L. Never mind, I can find N first. Okay, I can find N first. So you find N, 492N equals to 410 N plus 1. So 492N equals to 410N plus 410. rearrange the equations, I have 82n equals to 410. So n is equals to, now let's see, okay, let's see what is the value. 410 divided by 2. So I have a fifth harmonic here. So n equals to 5. Now that I have n equals to 5, I can just plug into any of the equations to determine the values of v. Okay, so sekarang saya ada n equals to 5, so kamu boleh je masuk ke dalam equations mana-mana to find out what is the value for a v. Okay, so let's see. I'm going to plug it into the first equations. Okay, so 410 equals to nv over 2L. This is what we have right now, just now. Yeah. NV over 2L. Given the length is 2 meters long, therefore 410 is then equals to 5V over 2 times 2. Rearrange the equation. V is then equals to 328 meter per second. Okay, 328 meter per second. So that is how you solve it. Okay, that is how you solve it. You start from the general equations, and then from there you form two equations. Okay, you form two equations, which is nv over 410 equals to 2L, and then n plus 1v over 492 equals to 2L. Then you can solve it by using simultaneous equations. Okay, you can solve it by using simultaneous equations. And eventually you will obtain v equals to 328 ms negative 2. All right. So again, as usual, I give you 2 minutes to write it down. Okay, 2 minutes to write it down. So start from two general equations, and then you proceed to simultaneous equation. From there, you then solve the questions. Okay. Okay. So now let's proceed to questions 4. Okay, so questions 3, you just have to know whenever you are given two set of informations, you need to form two equations. Okay, now let's proceed to the last questions. Questions number 4. What is the frequency of the sound emitted by open-ended organ pipe? So again, you have an open-end air column or open-end pipe with the L is equals to 1.7 meter long. When sounding, it's a fundamental frequency. So now you have a fundamental frequency. So the speed of sound, so fundamental frequency, F equals to 1. F1. So the speed of sound in the air is 340 meter per second. So you're given V. So fundamental frequency, what is the equations? Okay, what is the equations? Actually, it's very simple. Now you have a V, you have an F, you have an L. F equals to NV over NV over 2L. Okay, that is what we know. And then we have, okay, now we don't have a, do we have a L? Yes, we have L, we have a V, and then we know this is a fundamental frequency. Therefore, it is straight away equals to 1 times 340 divided by 2 times 1.7. Straight away, you obtain the answer already. So this is a very straightforward question, okay, which is then equals to 100 hertz. So fundamental frequency is F1. Okay, F1, what does it mean? It means your N is equals to 1. Okay, this is your first harmonic. So N equals to 1. So therefore, I have 1 times 340 divided by 2 times 1.7, which is then equals to 100 hertz. Okay, so that is questions 4, and then that is the last questions for today's sections. So any questions? Any questions last? So if no questions, I think that's all for today. Okay, you all may leave the class now.
Madam,
Yes?
I asked you a question yesterday.
Oh, you asked me a question. Let me think. What is the questions right now? Yeah, let me stop the recording first because it's a different chapter.